Okay, another quick video. This is the problem one that's on the lab. Okay, we have, let's say there are three gears, R1 with radius R1, R2, and R3, and they're all connected and turning or something. And they form a triangle in the center, and we want to find the angle between the triangles so we can cut some beams or something to attach these. We draw this out, okay, so that we have and with all of these problems, we're going to do some math, and then we're going to convert it into MATLAB, and then we're going to solve it just as we would if we were using the calculator. So our triangle has sides A, B, and C, angles alpha, beta, and gamma. And we're going to use the law of cosines, which I've written here. And the first thing we're going to tackle is alpha, the angle alpha. So we have A squared equals B squared plus C squared minus 2BC cosine alpha. We rearrange the terms, solve for cosine of alpha, and now we have a mathematical expression that we can solve for. Okay, so let's start putting some of this into MATLAB. We come up here. R1 equals 4.5, R2 equals 10.5, R3 equals 15, A equals R1 plus R2, B equals R1 plus R3, and C equals R2 plus R3. And we want to convert this expression right into a MATLAB expression. So I'm going to zoom back a little bit here. Okay, and that expression is alpha 1 will equal A cosine D. I'm going to get it in degrees. Will equal parent, and look how I closed the parents there to make sure I didn't make a mistake. A squared minus B squared plus C squared, that's a quantity. And that whole quantity is divided by minus 2 times B times C, closed in parents, okay? And once I solve that, I'm going to go to MATLAB next and do that. And then I'm going to look at law of sines. A over sine alpha equals B over sine beta. And I can solve for beta because I have A, B, and sine alpha. So you could also do this with the law of cosines, the other angles. I don't care which way you do it, okay? Whichever way you feel more comfortable with, but you have to solve for the other angles. Okay, for the second part of this video, we're going to start a new live script like we usually do. Okay, and there it is. Let me shrink it down a little bit. I want it to fit in the window. Nice and neat. Okay, and hopefully you'll be able to see this a little bit better. And we'll call this lab 2 number 1. Okay, and let's make that a text, and we'll make that a heading. Wilkerson, let's make that right there, and let's go ahead and start out with the things that we should be doing anyhow. Clear. Okay, and I actually would like format compact, and then I'm just going to go ahead and do a section break so that I can execute that. And it's not going to do anything, of course. Now I'm going to go ahead and put my variables in here. R1 equals 4.5. R2 equals 10.5. R3 equals 15.0. A equals R1 plus R2. B equals R1 plus R3. And C equals R2 plus R3. Let me make sure I didn't make any mistakes. That looks all right. And now I'm going to put in my last expression for alpha, ALPHA1 will equal A cosine D, parent, in accordance with what I had before, A hat squared minus parent B hat squared plus C hat squared. Okay, let me put a little white space in here. I like that. I like white space. Whoops, no white space there. Right there. Okay, and then I'm going to divide that quantity by minus 2 times B times C. Close parens. Okay, and let's run this. And I got 35.9085, which I know is correct. And that should get you started on this homework. So have at it.